This is Dr. Bev Knox, and you are viewing my psychology tutorials. Learn psychology while you sleep. Analysis of variance is a statistical test to determine if all sample groups in a study are affected by the same factors, and if they are affected to the same degree. The groups are kept separate and tests are done independently, but the results are then compared. So, analysis of variance is also called ANOVA, A-N-O-V-A. It is an analysis tool used in statistics that splits an observed variability found inside a data set into two parts: systematic factors and random factors. The systematic factors have a statistical influence on a given data set, while the random factors do not. Analysts use the ANOVA test to determine the influence that independent variables have on the dependent variable in a regression study. The ANOVA test is the initial step in analyzing factors that affect a given data set. Once the test is finished, an analyst performs additional testing on the methodological factors. The ANOVA test allows a comparison of more than two groups at the same time to determine whether a relationship exists between them. The result of the ANOVA formula, the F statistic, also called the F ratio, allows for the analysis of multiple groups of data to determine the variability between samples and within samples. If no real difference exists between the groups tested, which is called the null hypothesis, the result of the ANOVA's F ratio statistic will be close to 1. Fluctuations in its sampling will likely follow the Fisher F description. This is actually a group of distribution functions with two characteristic numbers called the numerator degrees of freedom and the denominator degrees of freedom. Let's recap really quickly. Analysis of variance, or the ANOVA, is a statistical method that separates observed variance data into different components to use for additional tests. A one-way ANOVA is used for 3 or more groups of data to gain information about the relationship between the dependent and independent variables. If no true variance exists between the groups, the ANOVA's F ratio should equal close to 1.